Hello and welcome to this film about Ephyra anaerobic digestion technology. We're here at Energy Factory West at Sleeuwijk in the southwestern part of the Netherlands.
And here we will show you the anaerobic digestion technology called Ephyra, where sludge is converted into renewable biogas.
So we're going to guide you around the site and show you how the technology works. The wastewater treatment plant here at Sleeuwijk treats the wastewater from a population of around 200,000 people. Due to increasing pressures of additional population, sustainability goals and the need to achieve net zero, the Water Authority has invested in a new state-of-the-art sludge treatment facility. This treats all the sludge from this site as well as 9 sites in the surrounding area. This sludge treatment hub uses Ephyra anaerobic digestion technology, which is a game changer in terms of digestion efficiency. This means we maximise the amount of biogas we can recover for injection to the gas grid, and it minimises the volumes of sludge requiring off-site recycling or disposal. So, what are the advantages of Ephyra? Well, it can process twice the amount of sludge within the same reactor volume, and under like-for-like conditions with conventional digestion, it typically produces 20 to 30% more biogas. That means more energy recovered, and it means less potential downstream methane emissions that can be emitted to atmosphere. It also improves dewatering, and it minimises the volumes of sludge that need subsequent recycling or disposal. So, what's the secret behind Ephyra? We're going to take you through the innovative design and take a look around Sleeuwijk to explain how the technology works.
Water Authority Rivierenland selected a group of contractors that included the Ephyra technology of Royal Haskoning DHV as being the best and most efficient sludge processing technology for this site here in Sleeuwijk. Here, one single Ephyra tank was constructed. This tank consists of 3 interconnected compartments of about 800 cubic meters each, and the Ephyra treat both the local sludge of this site and the imported external sludge. From the Ephyra tank, the sludge is pumped towards a post-digester and a buffer to ensure that all the remaining biogas is captured and that greenhouse gas emissions are minimized.
Whilst conventional anaerobic digestion has been around for decades, these completely mixed systems are inherently inefficient for 2 main reasons. Firstly, in a completely mixed tank, as material leaves the system, in the digestate there will always be partially digested material that has not been in there for the applied retention time. Secondly, we have no control over the different microbial processes that are all happening simultaneously within that single tank. Conventional anaerobic digestion usually comprises a single, completely mixed tank reactor, sometimes with multiple tanks operating in parallel. However, within the Ephyra process, we're operating a plug-flow system, and that means either we have multiple tanks operating in series, or we have a purpose-built tank with multiple zones. Our self-learning recirculation loop then provides stability across the system. In this video, we aim to show you why Ephyra should become the industry standard for anaerobic digestion in order to meet water companies' sustainability objectives and to move towards net zero.
Since 20 years I've been researching wastewater treatment systems. During the past 8 years I focused on sludge digestion, of which Ephyra or cascading reactors is one of the systems. Cascading reactors are very well known to reduce the volume of biological systems. Often in these systems you have very large recycle flows. In the Ephyra we studied the decrease of this recycle flow, and eventually we have a very small flow and still get a very good biological process. Moreover, particles are forced to travel all the reactors, so they stay in the system long enough to be fully degraded, and that leads to higher biogas production. Our lab and pilot experiments showed that we have higher hydrolytic efficiency in the first reactors of the cascade system. Well, higher hydrolytic activity means that we get more degradation, faster degradation, and that means more methane and less waste in the end.
Behind me there are two sludge buffer tanks, and sludge is imported by trucks from other, smaller wastewater treatment plants. The waste-activated sludge from this site is combined with the other regional sludges and together thickened by a belt thickener, which results in a sludge mixture of about 8% dry solids, which is a lot higher than normally used in conventional digestion. From the belt thickener, the sludge is pumped to the Ephyra tank. The Ephyra tank consists of 3 interconnected compartments. The thickened sludge is pumped into the first compartment of the Ephyra tank. In this case, the sludge is gravity-fed to the second and eventually third and final compartment. In case the Ephyra setup uses individual tanks in series, the sludge is pumped in between the tanks. The sludge in each compartment is well mixed by mechanical top-entry mixers. pH and temperature are measured in each compartment individually as input for the Ephyra controller.
A unique aspect of the Ephyra process is a recirculation flow. Part of the sludge is returned from a third and final compartment by pumping back into the first compartment. The main objective of this patented feature is to return methane-producing bacteria and alkalinity into the first zone of the treatment process. This is controlled in real time with our machine learning controller, providing continual optimization and a stable digestion process.
We zijn 2 jaar in bedrijf met de Ephyra. Wij bedienen eigenlijk de controller. Het is een vrij robuuste installatie. De controller pakt het al heel makkelijk op. De gebruiksvriendelijkheid is zeer hoog. De invoerstromen van de slip, wat hier aan de voorkant binnenkomt, heeft geen invloed op de regelingen van de controller. Hij regelt dat gewoon perfect.
Within the Ephyra process, we have the opportunity to precipitate phosphorus as Sleeuwijk. On this site, we dose magnesium hydroxide into the second compartment where the phosphorus is precipitated into the sludge. We do this to avoid deposition within pipelines and other parts of the plant. It also improves dewaterability and it can enhance the agricultural value of the digestate after treatment. However, this is not always required and it's an optional feature of Ephyra.
In order to achieve net zero, the digesters are heated by means of a heat pump. That means that we are using recovered heat from the effluent. This is yet another unique feature at this wastewater treatment plant that is gaining a lot of interest from the industry. The biogas is collected in the gas balloon for final processing. The digested sludge is pumped towards the final dewatering step. Here in Sleeuwijk, this dewatering is done by centrifuges. Final dewatering ensures a high level of dry solids content. This is prior to odorless transfer into trucks. The sludge of this plant is eventually transported for disposal or recycling.
The biogas from the Ephyra process is upgraded here on site in the biogas upgrading facility, where it's converted into high-quality biomethane for injection into the national gas grid. This provides gas for the equivalent of 1,000 households in the nearby village of Rivierenland.
Thank you for joining us on this tour of the Energy Factory Sleeuwijk.
We think this is a great example of how Ephyra anaerobic digestion technology can contribute to a sustainable wastewater service. If you'd like to know more about Ephyra or how it could benefit your business, please get in touch.